our first panel here is going to be the Security and Infrastructure Challenges panel. And I'll give the stage to Eugene from EOS Tribe.
Thank you, everyone. We have a distinguished panel today of very technical experts in our community. So I'm proud to host this panel. So I'll let everyone to introduce themselves. You know most of our panelists, but I'll just let them shortly to introduce themselves.
Hello everyone, Johnny Zhao from EOSLaoMao, and EOSLaoMao is a Tokyo-based blog producer. We're trying to promote EOS in Japan.
Hi, my name is Dafeng from EOS Asia. We are blog producers focused on building tools such as My EOS Kit and dApps such as EOS Pixels, one of the most popular games. So I'm happy to take the panel.
Hi, I'm Igor. I'm head of technology at EOS Rio. We are a Brazilian-based blog producer focusing on enhancing the community in Latin America.
I'm Eric, CTO EOS Southwest Eden from Sweden. We are just trying to help wherever we can.
I'm Michael Yeates from eosDAC. We're the community-owned blog producer and DAC enabler.
Stanislav Sinyagin. I'm known as CC32D9. Basically, I'm a developer. I'm not a blog producer. I'm trying to develop new technologies. But with my public real name, some people might know me since like 20 years already.
Okay, I would like to thank you everyone. I would like to start with questions which are, come in number of priorities, which is almost on everyone's mind, especially for blog producers and distributed apps developers. And the question one that I want everyone to express their opinion is, current issue with history API, and there's some development ongoing, which we are involved as well. But I wanted to, panelists to express their opinion and experience so far.
Okay. Apologize from EOSLaoMao because our history API went down when we failed to sync up with the 600 gigabytes RAM, and it's still not going. And since then we trying to find alternatives to provide API through other methods, and that's why we built ES plugin, and we're trying to sync up ES instance cluster to provide ES API to developers to somehow address this issue. And last night, I think EOS Rio, EOS Tribe, we are formed a group to standardize the API based on ES. That's pretty much what we'll get.
Just to give a bit of background on this history API thing. So history API was a part of the original EOS software release. It's a plugin that when you enable and you add on some filters, people will be able to query transaction histories of accounts, and that was very useful for like wallets, right? For people who use a wallet and want to see how many, what are the transactions that happen in the past, to which accounts, to which smart contract. They use this API to call. And shortly after the mainnet was launched, this history API thing was marked as deprecated, with no replacement. And it was marked as deprecated because the design of history API was not meant for scale. It stored everything in memory. It stored everything in memory, and with so much transactions happening on EOS right now, if you store the entire transaction history in the memory, your memory is going to blow up. And we knew that this would come, but we just didn't know that it will happen so fast, right? And the memory consumption was increasing crazily. We have 3 machines that's of 1 terabyte of RAM, and we were like replaying it. As soon as it finished replaying, the memory exceed 1 terabyte. And if you look at the cost of 3 1 terabyte machines, it's from cost and from every angle, it just doesn't make sense anymore with the solution. But because the deprecation happened only after the mainnet launch, and there was no warning and all those before, it took time for us to build alternative solutions. Solutions such as basing on Elasticsearch, solutions such as basing on Mongo. And so our API servers went down a few days ago. Those 1 terabyte machines, we have 2 terabyte machines immediately trying to replay, but then the cost was just too high. Or we were supporting a huge part of traffic in Asia Pacific region before. About 70% of Asia Pacific APIs went through our server, and when we went down, it was a huge problem for all the gambling dApps.
And the wallets.
And the wallets, obviously, that's the most important part. So we knew that this would come. We just didn't know that it happened so fast.
Yeah.
Right now, we are sponsoring projects to work on. We have internally been working on this problem as well. We have a solution that basically sends all the actions and history to a Kafka node, and then pipe it to Elasticsearch or pipe it to MySQL to do it. It's just we didn't have enough time to get it ready before the history API crashed. So that's the state where we are now, and I think this is one of the most urgent problem because we simply do not have enough API servers that's available on mainnet.
When you guys went down and Greymass went down and everyone, we were the last API for quite some time and we couldn't cope up with it. It was just amazing. I mean, it ate like 1.35 terabytes, I think, of raw memory on that machine, and so, and then our crashed down as well. So it's replaying right now and should be up in about a few hours, I think. But now Greymass has gotten there up, so we actually have some access now again, at least. So.
Yeah. And I turned up MongoDB to date, so we have API.eosReuse running on MongoDB, but there are some differences. So in terms of the structure of the output, MongoDB, the API provided by CryptoFinance, we have to thank for that. It's a little different from the API, the native history API from Block 1. And in considering this, I think we need to focus now on building a new standard, focus in exactly what we need to provide to the users. So this is, I think, our goal now, because we have like 3 fronts. We have people building Elasticsearch. We have our Elasticsearch cluster on Hyperion ready for 3 months right now, and indexed with all the actions. But we can't provide simply an API if there's no standard. Yeah. And also MongoDB and the solution that Stanislav is building. So I welcome everyone that wants to think on this to join our group on Telegram and provide feedback on what's the best approach to create a new standard for the API.
Yeah, nothing much more to add really. It's a Sisyphean task to try to run a history plugin at the moment. We've been providing a basic set of history for quite a while, but even our history nodes are all dying at the moment, and it's reflected across the network. Everything's dying. So yeah, we're building a Mongo replicant, the kind of similar to the history API, and I see that as a good medium-term solution, and then we'll look forward to some more longer-term solutions.
It's very hard to know how long it's going to last, but we have a few machines. We have ordered some more parts now, so at least we're going to be able to keep the history up for quite some time. So we have a little bit more time to try to figure out exactly how to do this, but it's a mess.
And I would like to introduce Stanislav before he starts. I reached out to Stanislav, and we started this initiative to build that new, history plugins that will be able to keep up with the load without performance impact on Nadeo's instance, because it does have performance impact. So we have built, there's a number of BPs who fund this initiative, and Stanislav is our, lead engineer and architect who is actually spearheading this effort. So that's why I wanted him to be on this panel.
So, well, sorry for being so late and slow in this development. Basically, I started working on this around July or something. When well, my first task was to make kind of accounting report, right? So I have my own company, and I want to have transparent reporting of my EOS transactions, so that my accountant can see basically the end of quarter reports. And so there was this history plugin, and I saw that it's not really doing well already. In July, it was already not a perfect thing to use. So I started experimenting, and out of that experience, I've got this ZeroMQ plugin. It's basically collecting within Node.js process. It's collecting balances and well, the most important is basically token balances, and exports them in JSON format through ZeroMQ plugin. It works pretty well, but basically if you try to store this amount of data on some kind of a database, it's again the same problem with performance and space. I have now basically my test server, which is storing this in MySQL database. It's synchronizing since about 1.5 weeks. Now it's around 24th of October, so maybe, and it's running out of memory. I see that basically it starts swapping, and yeah. So that's basically prehistory. Plus, one of the challenges within Node.js is microforks. So basically, it happens mostly between when this handover time, when block producer A finishes its work and then block producer B starts its work. There might be like last few transactions which didn't make it to basically were broadcasted as signed, but then it was too late, and then the next block producer needs to re-evaluate and re-insert them in the block again. So you get a microfork, so you get exactly the same transaction with the same input, but it happened at different moment in time. It happened also, it has different global sequence identifier, global sequence number, and it might actually have a different result because it's starting from a different time point.
But they're only appearing in one irreversible block, right?
Sorry?
They are only appearing in one irreversible block, right?
They are. Yeah, basically in irreversible block you see that once, but irreversible block comes a few minutes late. If you need it in real time, you basically see this transaction, you start processing its output. Few minutes later you get the same transaction again with a different input already, right? So you need to erase what you saw before and start recording again. And basically at the moment there are only 2 plugins which are handling this properly. There's this Todd Fleming's state history plugin, which is not released yet, but there he is basically doing it correctly, so that the receiver gets notification that all that you've seen up to this block is false. Please get a new data. And basically I just copied what he done into the ZeroMQ plugin, which is also basically sending an event that basically these transactions were bad. Here's the new input, and then the receiving part has to really somehow delete that from the database and start reinserting. And that's of course a lot of processing resource that is required to actually undo and then replay again. So so basically back to what we are building now. We are trying to get best of what we've got already in our experience into something new and scalable. I think what Todd Fleming is releasing is basically the ultimate solution for exporting data, because basically he's invested a lot of time into building and testing it. It's delivering all traces and all table changes. So basically, whenever a transaction changes any table in a smart contract, this data is exported outside of NodeOS, but it is exported in binary format. So you need to have ABI to decode that and process it. So, but at least exporting part is implemented. That means basically out of that fund, I don't have to spend time on exporting anymore. The challenge is to basically to receive this information, decode it according to ABIs, and deduplicate, because we want to have redundant solution, right? So if you have several node OS producing the same type of information, there should be some node which is removing the duplicates and then exporting this for further processing, like this Kafka queues, which allow you to store this for long-term storage or for some real-time event processing. So that is one challenge that is going to be addressed basically now, that I'm working on is basically accepting this data, sorting it out, decoding, deduplicating, next step, and then storing it. For storing, there's Apache Cassandra project, which is very scalable database. It's written in Java. Said has proposed, there's a clone of Apache Cassandra called ScyllaDB. ScyllaDB is basically re-implementing Cassandra, but in C++. So it's promising to be much more performant, especially that we have a huge amount of data that is coming in real time. So basically, and out of the box in ScyllaDB we get replication, which means you can distribute this data among multiple physical nodes and then feed your customers from distributed cluster, also just geographically distributed. So we can basically produce it on one continent and then distribute this data across the whole world, for example, or have several independent sources of this information. So that is basically some nearest future, is to actually design some kind of a public service, maybe doing it as a shared initiative. But it's promising to be much less demanding in resources. You don't need a terabyte of RAM to process that. You just need enough memory for caching. Basically, you need some disk performance. With this history plugin, one of the challenges is actually that you can use SSD for storing this terabyte of data, but it's read and the read-write is in small chunks, in totally random.
Yeah.
Basically, across your terabyte of your file, your reads and writes are totally random and sporadic, and caching is very difficult. So,
could I add here?
Yeah.
For the history plugin, we get quite good performance running the Intel P4800X for data center as RAM. The license isn't fun, but there's a possibility to add NVMe drives that you can actually get decent performance out of using the history plugin.
It's about 4 times cheaper than actual physical RAM, and we don't get much difference in performance.
We have been
for some specific workload.
Yes, thank you, Stanislav, for giving such a detailed overview of history plugin, and I believe it's important enough topic, and I'm sure some of the audience have questions, so I would like to open for questions to audience on this topic.
Hi, this may be a silly question, but have we considered compression as part of managing the data before storing onto a database, and maybe the more kind of traditional relational database that obviously will benefit from it?
Some people are using encryption, compression on CFS. with quite good performance.
I know from our interaction with Stanislav that in a channel that where we work on this new history plugin, we have discussed LZ4 as a possible candidate, for compression, because that would significantly improve just data storage requirements. It's a very verbose, where you store in JSON is very verbose format, obviously. By if we archiving it on read and write, that would make our footprint on hard drive is much smaller, right? So we have discussed it, and LZ4 is good.
It is ongoing right now. Greymass is now they just brought up their old server with ZFS with compression, and they try to store this. They just synchronizing now this history plugin with all history on compressed ZFS. It's going so far good. It's about two to three times compression factor. So basically, it means. And LZ4 is very fast in terms of CPU performance, CPU requirements, and ZFS is also distributing this compression load across CPU cores. So it looks very promising, but there's no result yet. It's still synchronizing, so probably in a few days we get some test results and maybe recommendations for launching this. I have also a server which is storing JSON format in MySQL, and I started also compressing that data, and basically compared to almost how much? It was about half a terabyte before. Now it's about 200 gigabytes. So compression factor for JSON is enormous, and the good thing about compression is that it saves you disk input, disk writing. So, which is the slowest part is disks. Even if you have a huge RAID array across SSD, it's still the slowest part to store this data. So, and with this new project that we have, I hope I didn't yet look at how ScyllaDB is storing data. I hope that we can store data in sequential writes, not in random writes like we have now in history plugin. That will improve a lot because lots of storage systems they are optimized for sequential writing. So I hope we get some gain, some benefit there as well.
So guys, impressive work. Thank you for that. One kind of fundamental question in a off-chain world, legal world, I have to keep papers, contract invoices for let's say 10 years. How we are going to deal with the storage issue long term? Are we going to throw away some data somewhere? How we are going to index that? What are the patterns and terms? What are the principles? Do we have an because these are the questions that especially business use cases are asking. Can I trust to the ledger that in 10 years from now on the data will be still there, the transactions?
Sure. Well, our approach to that is we'll be using probably Cassandra to keep a long-term storage forever and without indexing all the internal structure of the actions. And for a short term, like 6 months or maybe 1 year, we can keep that indexed on Elasticsearch, where we can have queries available from every structure inside of the actions. So for past data, you will be able to query the transaction hash or fetch a old block or something, a transaction, not a block, because a block you can just fetch on the chain base. That's for long term. So you won't be able to say to make a query to see the number of actions that transfer 1,000 EOS to a single account, but you will be able to get a specific transaction for long term. And while in the short term, you will be able to query and make any type of analytics on top of it.
So our thoughts are, just to add on to that, our thoughts are very similar, and I don't think this is something that we need to worry too much about, because the technology problem has been solved in the internet world. There's a lot more data in there. It's just not stored in RAM, and it's not sporadic. As long as you do it sequentially, there's a lot of database that's optimized for doing that. There's sharding you can do, and there's also you can shard it based on the time as well.
The only point is who is going to fund the required infrastructure for that long term. I mean, are the BPs, do we have enough revenues to do that? I mean, this is a serious business.
Right. I think the fundamental problem I see with the history API problem right now is that the software, when the EOS mainnet was launched, the software has a history API. So everybody took that as the standard, the convention, and now with the implementation of that doesn't scale. We now either do not have a convention for the new implementation, or we need to stick with the old one, and and there's a lot of problems with that. Like there's lack of standard, and there's a lack of a mature implementation yet. As you see, there's a lot of implementation of details, and to be frank, the BP pay doesn't really allow one individual block producer to build a project of this scale. So that's why projects that's crowdfunded by BPs and people who care about this enough came out. And this is I think we need to, as a community together, we need to find a way to sponsor this type of projects more. These are the projects that not one single team can take alone.
So you're actually asking about storing in the block log, and we are talking about accessing the data. Yeah. So the block log is only about 100 gigabytes right now. So there's no problem to store long term. I mean, the usage can of course go up, but I think we're basically where currently, until we get multi-core, we cannot process so much more transactions. We cannot add that much more data to it. So I don't think the storage requirement of the block log is going to. Of course, it might go up a little bit, but it will not probably get.
The block log is always your single source of truth, and like he says, storing that is fairly easy. So if you can take the block log and then extract the data that you require for your business, it's not a problem. We've always got that block log, which, yeah, it's easy, no problem.
I also never thought it was actually meant for the BPs to provide full history nodes. It's just something that we do because we believe that we need to do what we can to help the community get a support. I mean, you could add whatever filter you want to your own history or whatever you're going to run, and that's probably how things are supposed to work, in my opinion.
Yeah, this kind of goes into what I was about to say, which is that not everybody understands the kind of the dynamic between the block log and the history API. So just to summarize quickly, right? The block log is a very compressed blockchain format, but if you to go back to your real world analogy, right? If you think about how lawyers handle paperwork today, right? There's stuff that they have active with their active clients, and then they put it in a folder, they put it in a box that goes into a storage shed somewhere. And if somebody wants archived data, they just know it's going to take a long time, right? So I don't think the expectation is, or should be, for people to be able to access all of history immediately. I think that those solutions of gaining access to very old data will evolve over time. But part of what I think needs to happen with the community is conversations about how to think about things, right? Because today when we see it today with wallets, for example, right? You got users that store their keys in Notepad, and then you got users that are like obsessed with security on like Ledger, right? There's like where's the middle ground? Like the people haven't started having these conversations about how we think about these things correctly. And even with if we look at the dynamic of the history API plugin today, you have this this insane replay logic, right? Which is like, okay, so so something went wrong in this massive monolithic process. So what do we do? We start a multi-day replay process. It's ridiculous. I mean, clearly, if we look at there needs to be more chunked ways of recovering to a point in time, right, where we can validate blocks of data, so that we're not we can download a binary stream of signed data. It has this hash. Cool. We can start from that point and move forward.
That's actually what I am doing. I'm replaying up to a specific block, and then I'm taking that and putting it aside.
Yeah. So what I'm saying is that whatever solution we come up with for the future, for these new indexed structures, should encompass logic that doesn't require us to. We should be able to take a snap, have an agreed upon standard that we can move from a particular point in time forward, so that we don't put ourselves back in this position where we are replaying from the beginning of time, because let's face it, that's just going to get worse and worse, right?
Thank you, guys. I would like to move on to the next topic, so because we have a limited time frame, and EOS blockchain is growing rapidly. You know, it's a very fast blockchain. We have number of transactions increasing constantly, and that just creates more pressure. And I don't see any slowing down. With more distributed applications coming on blockchain, we will just see more and more of it. And I just wanted to get your kind of predictions and opinions on what it will take for infrastructure for 2019. You know, what we will all need to have some, you know, serious upgrades to meet that demand as block producers. And I just wanted to, you know, get your opinion.
I think we'll start to see a lot more side chains appearing, and this means we need to prepare our setups for, not our setup, but the tooling and everything to be able to utilize resources from multiple chains. I think this will be something that we'll start to see, because the mainnet right now, it won't be able to allow every single type of application, and this will be a scaling limit for it.
I agree with you. Really nothing to add. I mean, we are going to see multiple chains. As producers, we should prepare for it. We should have done that already. We have. So just make sure that when you are thinking about running multiple chains on the same machine, what you need to do is to use separate storage for each and every one of them. That's basically the only thing you need to do, and make sure that your CPU is scaling up. Looking at for example, how you set up the C states and P states, those things are obviously becoming more and more important the more Node.js processes you're running on the same machine. And there's a lot to do.
Yeah, so we're going to see increased disk requirements. I think we're starting to look more and more at the storage on disk. And yeah, like they say, the side chains, we're going to probably running 2 to 3 chains per machine. And then we need to look very hard at the APIs, and like the guys say, is like, what do we offer as a BP? What is our core service, and what should be provided by the dApps? And we're going to need to draw some lines there soon.
So this is going to be old before I said it, because we're getting away from the history API. But when we talk about running multiple chains on the same machine, we're probably not talking about running one machine where we produce for multiple chains. We're probably going to have one producer, one history, and one peering node, or maybe 2 peering nodes on the same machine, which means that we're going to use the machines for specific things for the other chains.
I have something to add. Because we run our server on cloud, we now use Google Cloud to run servers, and because Node.js now is a single-threaded process, and a lot of cloud service, Google Cloud, they don't guarantee that you run a specific kind of hardware, and so for us, we're seeing our CPU performance is not that kind of high, so we're trying to maybe shift to AWS, or even set up a bare metal machine, and also we are looking forward to maybe multi-threaded support from Node.js, and of course IBC. I think if there comes the RBC solution, there might be some, take some loads from mainnet to other side chains, and yeah.
Yeah. So I think Zhao Yu made a very good point that right now the performance characteristic of running a mainnet chain, the resource requirement for machines are very clear already. For people who are previously on cloud, I think it's time to move on to more bare metal so that you have a more control over the granularity of machines that you want to provide and performance you want to provide. One of the things that I think in terms of infrastructure preparations, I actually think that when the CPU has problem on mainnet, when users are crying that they can't play things, they have trouble transferring, we're seeing very limited usage of resource on our actual infrastructure. Now, there are two folds in that. One is in terms of the CPU, like the resource allocation model on EOS, it has a threshold. Like once you reach that threshold, then the resource allocation will kick in and then check who has staked this amount of token, and then what's the proportional CPU resource that he can use. The biggest problem with that, and we've been tweaking this parameter up and down and seeing what happens. The biggest problem with that is a lot of people, they stake not because they need the resource, but because they want to vote for certain block producers, and they're not really using that resource at all. So you see whales that's stake like huge amount of token. For example, B1 account is staked a huge amount of token, but they're not really using that much of the CPU resource. They don't run mega dApps. So whereas there are dApps that require that much of a resource, they don't stake that much token. So we're seeing a problem, which is we couple the right to vote and the right to use resources. And if we don't decouple them, then we will constantly face this problem. So we're seeing projects like Chintai, we're seeing projects like Bank of Stake that's trying to facilitate this, moving the liquidity of the, trying to decouple this a little bit more. But on a massive scale, we're not seeing that yet. So for example, we're not seeing mega whales doing those. And they are the people who stake the most tokens. So the solution has already been proposed, which is using Rex. Essentially, it's basically decoupling that. So I'm really looking forward to the actual implementation of Rex, and then seeing how that will help with the resource allocation. Because frankly, when the resource limit hits, our machines are doing just fine. And obviously with multi-core, we're going to be using much more of the infrastructure. So aside from choosing a more suitable machine, I don't think there's much to prepare in terms of the infrastructure side. It's running quite fine.
Just add that obviously we have no idea what the requirements will be, because we don't even know how the multi-core signature that we will get soon will affect anything, and there are so many unknowns still.
And also that the CPU problem, when we are seeing like some BP missing the last block, and some people related that to the increase in the target CPU, but I think that's more of a network problem than a CPU problem. So we don't have time to propagate the blocks, not exactly that the machine doesn't have time to process that.
There may well be other factors there with blacklist checking, with high transactions. But yeah, I'll just reiterate what Dafeng said. I think he's exactly right. We staked way too much when we launched the network, and many people have staked tokens who are not actually using the resources. So yeah, people probably need to unstake, or we need to find some way to decouple the voting from the staking. And also a lot of people use staking as a security measure. So possibly locking tokens rather than staking tokens could be the security and the voting indicator.
Thank you. We kind of just drove right next to my topic on CPU solution, and yeah, please continue.
Yeah, just a short. It's not only network; it's also disk latency, especially for cloud solutions. I just had some infrastructure servers for one of the casinos in. It was VMware hosting with some shared SSD massive storage, but it has this tiny latency difference which accumulated basically. So Node.js is trying to read and write, and ZFS is also trying to do its own job to do some reading and writing, and basically the node is just collapsed because of too many transactions, too many reads and writes. We moved it to a physical machine, and it's all nice and clean, and it's quiet totally. So there's this tiny difference in I/O delay, basically, is the key factor as well. It's not only network.
I'll just add to that. Running ZFS with the optanes as memory is probably not a good idea. I haven't been able to dig into it a lot, but it also seems to add, I think it's moving, CFS is optimized to use a lot of memory, so I think it's moving around a lot of cache to the memory, and the data rates are not really what the optanes are good at.
We have done some profiling between NVMe and Optane. Just to share some of the, our findings, we found that Optanes give a much better performance on reads, but they're comparable to writes with NVMe. NVMe are much cheaper than Optane. So for Node.js process having a mostly heavy write I/O operations, you're probably getting better return on your investment just using NVMe.
Yeah, but just not to use the word Optane here, what you're talking about, because the Optane line was like a broad range of projects where you have that hard drive optimizer memory that people put in laptops. You have the 905p, which is a gaming solution. You have the data center class, that's a completely different product. So and the P4800X, it's made to be used as RAM, not as disk. So in that case, you should use that disk to increase the RAM capability of the machines, and you should use the P4610, which can go to 6.4 terabytes as actual storage, and they are almost like 3 times as fast as a standard NVMe.
Okay.
But using the P48 as storage, it's actually bad because it's not meant for that, and it's slow.
It's very good for latency. That's what it's done for.
Yeah.
And NVMe can go around to 30 to 45 microseconds of writing latency. Sorry.
Okay. Thank you. And related to latency, I would like to cover a next topic for network latency, and some of the performance that we can do. One obvious one is just a simple ordering of block producers. It doesn't make sense sometimes, to jump from, let's say, Sweden to US when it comes to an order of block producers because of latency. If we can schedule it in more like a geographical, and some research have been done in this area, how to optimize it and to decrease latency between block producers. So I would like to get your feedback on that as well.
So I wrote a very quick patch which has not been tested. It compiles, which is always good, which will actually change the ordering from the alphabetical ordering to a location-based ordering, which is set by us, and we're going to set regions. So each producer will declare their region, and then within that region we're ordered. So it should help a lot from the handoffs between each one. Between the regions, we may have some issues like going through the Middle East. We don't have too much in the Middle East, so we're going to hop straight from China to Europe. But it's going to make things better. It's not going to be worse, hopefully. We need to test it on Kylin and put it through its paces. But yeah, I think it's a logical progression from what we have now, and it probably can't be much worse.
It can be gamed slightly by the producers, but I think that I actually think that the producers will feel that it's more important to cooperate on this, because one of the producer has to take the big jumps, right? Who want to do that? And if we are going into measuring stats for the different. This is actually a hard thing. Measuring these kind of stats, whatever you can measure, you can game, and so if you're one of the producers who's actually taking one of the bigger jumps, your stats are going to look worse, but you're actually doing something good for the network. So I think it won't be a problem, but it could be gamed by some of the producers.
I think a lot of people look at missed blocks on producers and they think it's a sign of a bad producer, but it isn't necessarily. It's we're not entirely sure what's causing all these problems. It could be the blacklist. It could be the guy after you who's causing the problems. So we just need to change our metrics slightly to see, to not focus so much on the missed blocks, but maybe focus more on latencies. Or
for about a week now, I have on Kylen testnet been taking away EOS Store's last block. So they miss a block every round. And I do that on purpose. I've also made sure that I'm not missing a single block on that one because I'm not filling up my blocks with any transactions. So it's very easy to game these kind of things.
How we are doing on time? I would like to open, for questions.
Yeah, we have about 10 more minutes or so.
Okay, good. Do you have any?
So we've been talking about that particular solution for a while now. What are the next steps? What are we waiting for in order to be able to test it on Kyling, or to mass test it in order to be able to actually action it?
at the moment, we're working through some other tests of some updates to the system contracts. So we probably only want to test one thing at a time. So first thing is to test the new 1.4 system, 1.5 now? Is it out now? Okay. The latest system contracts we need to test and deploy and test. Once those are okay, then we can start to do these other more experimental changes.
It was a really good point that you brought up about how producers are sometimes evaluated, and there's that that old YouTube video that describes this light experiment where, depending on whether or not there's actually an observer, the light will behave differently, whether it behaves as a wave or a particle. So if you're looking at these metrics by themselves, it's fine, but as soon as they start to be a measurement of whether or not a producer is good or not, you might see them shift because the producer is aware and they're starting to game it. So is there a kind of standard that can be used to indicate the strength of a block producer group? Or how would you start to engage the community who doesn't necessarily possess the technical understanding to get a lot of this stuff, to say we need to use these as a guidance but not as full direction on BP strength?
Yeah, I think missed blocks in particular, they indicate the health of the network. So if the network as a whole is missing much more blocks than yesterday, then yeah, something's wrong, like when we increase the CPU. In terms of individual producers, I'd say probably the CPU benchmarks that we have via Aloha EOS are probably the best and most objective test that we have now. And that reflects on the users, because if we build CPU for less, then they're able to make more transactions.
So, I'm going to throw a concept at you guys, and bear with me here. So today, staking resources on the network gives you access to CPU and net, right? One of the ideas that I was playing with was being able to measure your API usage via the amount of staked EOS that you have, right? So basically the idea that by being an EOS token holder, it entitles you to a certain amount of API usage, right? So today, what we have is we have a floodgate, right? Which we'll all just provide APIs, and if you want to abuse the hell out of it, well, you just go and take everything I got. That's our current model, right? So if there was an effective way for, let's say, a token holder to create an API key, which let's say he used his some signing key to sign something that showed that he is a token holder. When that API request hits an API node, you have some way to validate what his balance is, right, on via an API node. You move to a model where API usage becomes just another resource that he has rights to on the network. What do you guys think of that idea?
I think it would slow down a little bit, because you'll be signing and verifying requests at every single request, and now we are doing, I don't know, maybe Grey Mass is having more than that, but we have been doing like 4,000 to 5,000 requests per second, and from different places. So not always there are users that are spamming the APIs. They're just trying to see their account balances on some block explorer or something like that, and that will be harder if you really want to sign everything. How you do, like, open your phone and go to any browser and check your account, for instance.
Yeah,
or that block explorer might need a massive stake for API requests.
Well, if you, I guess what I was thinking is, like, when you log into a DApp, right? Quite often you log into a DApp and provide your identity somehow, right? So when you do that, you would essentially generate an API key once, right? And on the receiving end, it would only really need to validate that key once to know that you're a valid user, and you can cache that for a period of time. There's a number of technical challenges. There's kind of two aspects to it, right? One, does it conceptually make sense, and then two, like, can it be achieved technically?
If you can build it, do it.
I think this relates to just to facilitate this question. I think it relates to subscription model in general, right? And we may have that demand from the network or from certain large distributed apps that wants a dedicated endpoint which is reliable, so that they don't use a public one, and they would be willing to pay certain subscription cost. So it's an option to consider at least.
I run some other ones that are hidden to be able to access the network faster. Yeah, and I think that's up to everyone to do as they please.
I think from a business point of view, we're looking at a network now which is in its infancy, and if we're looking to grow to global levels, this is unsustainable to keep our API nodes just abused constantly. So yeah, I think we are going to have to do something where maybe there is a small public API, but if you want more serious use, then you stake or pay.
And the other side to that sword is, of course, that we want to make it as easy as for everyone to use it as much as they have to be able to scale their, or actually focus on building what they want to build. So I think it's a two-edged sword.
I want to talk about this a little bit. I think when we have the net and CPU and RAM as resource, it's already very confusing for normal users. The user experience is going to hurt so much more if we introduce one more resource. I would actually think about cutting some of this to make it easier for people to use. Now, I understand the challenge, which is for us to, as block producers, as network providers, we're providing API service, but this is more of a technical challenge. I feel like we shouldn't offload this burden by creating additional concept for all the users. This concept could be created to people who need it, like DApp developers. When you need like premium access, more stable, that's a technical conversation that shouldn't bring in another concept for the entire network users.
Thank you. I would like to wrap up this panel. Thank you everyone for participating, and thank you.
Thanks.
All right. Thank you, Eugene. Thank you, everyone.